Hi everybody. In this video we are going to introduce the 6 trigonometric functions. And we're going to introduce them from three possible perspectives. The first one is from the standard angle that we actually discussed in one of our previous videos. We are also going to introduce it from the perspective of a right triangle, and you can sort of see the relationship between a standard angle and a right triangle here for any given angle theta. And finally, we are going to introduce it from the perspective of a unit circle, where this radius basically just walls you around the unit circle for a certain angle theta. And although this is probably the most abstract version of it, is also the one that gives us the most utility, particularly when we start thinking about time signals that actually have a sine and cosine behavior towards it. But first we're going to start off with standard angle, okay? And here we're going to let xy be a point, not necessarily the origin, because that doesn't do anything for us, on the terminal side of an angle in standard position. So here is our angle in standard position, and xy can be any point along here. We're going to just assume that it is here. So its x value here is x, and its y value here is y. If that's the case, then our trigonometric functions of theta is going to be defined as the ratio between y and r for sine theta. And also keep in mind that r is a distance from the origin to that point. So that distance is always going to be positive. R is always greater than 0. Okay? Now cosine is defined as x divided by r. Okay, tangent, also known as the slope here, is the ratio between y divided by x, okay, its height divided by its length. Cotangent is the reciprocal of that, and that kind of gives you insight to one of the many trigonometric identities that we're going to talk about. Secant is the ratio from r over x, which of course is the reciprocal of cosine. And finally, CSE or cosecant is the ratio of r over y. For the case, obviously, where y is not equal to 0, and that is reciprocal to sine. And with that in mind, we are going to use these definitions, to find the trig values for certain angles. Now here, we have an angle that is defined, but we have an angle, and we know one point on this angle is going to be the point 8, -6. So this happens to be in quadrant 4. Okay. It turns out that if this is 8, -6, it turns out that this distance here is going to be 8 squared plus -6 squared, which is 100, or basically the square root of 100, which is 10. So in this case, r is equal to 10. So the question here is, what is sine theta? Okay, well, sine theta is going to be y, which is -6 divided by 10. Okay, we can we can go ahead and reduce that into -3/5. Okay, once we know that, we know what cosecant is, because remember, they're just reciprocal. So this is going to be -5/3. Okay, what about cosine? Well, cosine, x is 8, r is 10. That reduces to 4/5. What is secant? Well, it's going to be the reciprocal of that, 5/4. All right, what about tangent? Well, y is -6. X is 8. That reduces to -3/4. And then cotangent is just the reciprocal of that, which would be -4/3. Next one is a little bit trickier, but not really so bad. Notice here that we have we have this equation in standard form. If you put it in slope-intercept form, you're going to get something like this. So when x is equal to a certain number, y is going to be 3/2 times x. So suppose that x is equal to 1. Okay? Well then, let's suppose that x is equal to 2. That's probably better. Then y is going to be 3/2 times 2, or namely 3. Okay? Now if that's the case, r is going to be the square root of x squared, which is 4, plus y squared, which is 9, which is going to give us a square root of 13. And since 13 is a prime number, we can't reduce that anymore. But notice here, we have an x, we have a y, and we have an r. So we can go ahead and do the exact same thing that we did before. The sine of theta here is going to be y divided, no, I'm sorry, y is 3. We can fix that. 3 divided by the square root of 13. Now, we will probably need to rationalize our number, and if we do, we'll multiply both sides, the top, the numerator, and denominator by the square root of 13, and that will give us 3 root 13 divided by 13. Now, for secant, that's just cosecant, that's just reciprocal of that, so that will be the square root of 13 divided by 3. We don't need to do anything else because here our denominator is rationalized. Now, cosine is going to be x, which is 2, divided by the square root of 13. Rationalizing the denominator, we will have 2 times the square root of 13 divided by 13. Okay, and then finally, and then for secant, that's the reciprocal of that. That will be the square root of 13 divided by 2. Notice that since this is not there's no radical down here, we don't need to rationalize. And then finally, for tangent, y is equal to 3. X is equal to 2. There you go. Tangent of theta here is 3/2. Cotangent is reciprocal of that, 2/3. So that is an example of an angle in quadrant 1. We did one angle in quadrant 2. Let's take a look at a quadrantial angle. So here, we want to find the 6 trigonometric values for an angle in standard position that is passing through the point 0,5. So this right here is 270 degrees. In this case, x is equal to 0, y is equal to -5. Remember, r is always going to be the distance from here to that point, which is always going to be positive. So this will be positive. Okay, so what is the sine of theta? Well, theta is going to be it's going to be y over r, which is -5 divided by 5, which will give you -1. Okay. The cosecant of theta is going to be the reciprocal of sine theta, which is, once again, is -1. Okay, what about cosine theta? Well, that is going to be 0 divided by 5, which is going to be 0. Okay, the secant of theta is going to be reciprocal of that. Now, notice that the reciprocal of that is going to be 5 divided by 0. We cannot divide by 0, so this is going to be undefined. Okay, and now for tangent of theta, well, remember, here y is equal to -5 and x is equal to 0. Once again, that is undefined. And then finally, cotangent is here, x is equal to 0, y is equal to -5. 0 divided by -5 happens to be equal to 0. Okay, so notice that when we have a case where the angles are on the are quadrantal, I can't say that correctly, then there will be at least 2 angles that happen to be undefined. Okay, so the conditions for finding the undefined values is as follows. If the terminal side lies on the x-axis, y-axis, which means that x will be equal to 0, then anything that causes division by 0 will be undefined, and that occurs for tangent, and that occurs for secant. On the other hand, if the terminal side lies on the x-axis, that implies that y is equal to 0. Okay, and anything that anything that causes the division by y, which is 0, is going to be undefined, and that will be cotangent, x over y, and cosecant, r over y, will also be undefined. We can also summarize all the values for every quadrantal angle, I think I said it right that time, by this particular table. Okay, and notice that for every single angle, there's basically 2 places where we're dividing by 0, or 2 functions where division by 0 occurs, and they'll be undefined. Now, even though I provided you with this table, I don't want you to memorize the table. I want you to realize that, okay, well, if we're dealing with 0 degrees, then this right here is the value, and we know that y is equal to 0, x is equal to some number, and then r is going to be equal to the exact same number, and then through those we can figure these things out. So even though I have this table here, I don't want you to memorize it. I want you to see the situation that's going on. So for example, here's -180. Okay, there x is equal to -alpha, y is equal to 0, and r is equal to alpha, which will give you these values right here. Okay, so I don't want you to memorize the table. I want you to learn the geometry, be able to picture this in your head. That is your mission for this particular. That is your mission for these types of angles, and for a number, and also for a number of reference angles that we will be talking about further in this course. And that's all I have for this video. If you have any questions, please feel free to contact me. This is Bob Boyle signing off.